Hello everyone, this is Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering from Department of Electrical and Electronics Engineering. So now the course is about power system operation and control. Here now we are going to discuss about modeling of governor mechanism or governor system. So coming to this, what is about modeling of governor mechanism or governor system? So a speed governor is also known as a speed limiter, or it may be treated as one of the controller. So it is a device which regulates the speed of the machine. So like a engine or turbine in a power system network, it is ready to go for the control of the speeds. So a governor protects the prime mover from overspeed and keeps the prime mover speed at or near the desired revolutions, which will be considered per minute time period. So the time factor is per minute. So when a prime mover drives an alternator supplying electric power at a given frequency, governor must be used to hold the prime mover at a speed that will yields the frequency. So it should ready to match with the frequency whatever the speed we are going to adjust. So what are the functionalities of the governor mechanism or governor system? So a speed governor controls the frequency of a power system. So by keeping the speed of the prime mover at or nearer the desired revolutions per minute, it also protects the prime mover from overspeeding. That means in some considerations due to which excitation is going to be hiked, then the speed of the prime mover is going to be increases. Speed of the prime mover is going to be increases. So due to which we need to control the speed of this prime mover. That's why we need certain mechanism called governing mechanism. So how it will be functions or how it works. So a speed governor detects speed deviations from a set point, converts the deviation into the signal and amplifies the signal to the trigger and actuator. So the speed governor is ready to detect the mechanism of setting the point and converts this deviation to the signal. This signal is passing to the amplifier and this amplifier will detect the whatever the triggering position or actuating position. So the actuator is now ready to control the flow of the water into the turbine or the input flow of the steam to the engine case. So likewise the speed governor mechanism is ready to work. So here when we consider one of the example, so here a centrifugal governor, it is also known as a fly ball governor. So this is an example of a speed governor mechanism. It uses the effect of inertial force on rotating weights to regulate the speed of a reciprocating steam engine. So this speed governor is ready to act as an error sensing device. So error sensing device, like it will ready to act, error sensing device. So this will be taken place in load frequency control. So it includes all the elements that are directly responsive to the speed and influences the other elements of the system to initiate the action. So the governor controlled valves are helpful to make this mechanism to be work sufficiently. So they are ready to control the input to the turbine and are actuated by the speed control mechanism. So this mechanism can be done by this speed governing system. Here is one of the overview of the power system control, that is the speed regulation of the governor. Another one is controls the boiler pressure, temperatures and flows. Next one is speed regulations concerned with the steam input to the turbine. Load is inversely proportional to the speed. Governor senses the speed and gives command signals. Steam input changed relative to the load requirement. So these are the possibilities for the power system control operations. So whenever there is a regulation of the speed, the governor is ready to act to the control action, and this will ready to control the boiler pressures, temperature variations, and whatever the inflows and outflows from this mechanism, and whatever the regulation of the speed that is related with the steam input to the turbine is considered. The load which will be inversely proportional to the speed is considered. So the governor is ready to make the signal for sensing the speed, and it will ready to use the command signals, and the steam input change is relative in nature to the load requirement. Likewise, we can make the simple overview of the power system control operation. What is governor control? How can we make this process? Means the governor is introduced to control the speed. So governor is a device used to control the speed of the prime mover. So it will ready to protect the prime mover from overspeed and keeps the prime mover speed at or near the desired revolutions that will be taken per minute. So when a prime mover drives an alternator supplying electrical power at a given frequency, so governor must be used to hold the prime mover at a speed that will yields this frequency. So an unloaded diesel engine will fly to pieces unless it is under governor control action. So likewise, governor control is ready to operate for the desired frequency levels. So here are some other control mechanisms. Those are called load frequency control, economic dispatch control. So what is load frequency control? So coming to load frequency control, it will sense the busbar frequency and the power frequency. So the busbar is considered nearer to the substations, which will be ready to operate at a suitable range of power frequencies. Next, difference given to the integrator and to the speed changer equipments. And it will be operated with the line frequency maintained constantly. And another case is economic dispatch problem. What is this economic dispatch problem? So here, when load distribution between number of generator units is considered optimum schedule affected, when it increases at one replaces and decreases at another end. So likewise, economic dispatch control will ready to operate. And second case is optimal use of generators at each station under various load conditions. These are known as economic dispatch control actions. Next case is automatic voltage regulators. So it is ready to regulate the generator voltage and output power. So here terminal voltage and reactive power is also ready to meet the requirement case. Next control is through system voltage. So it will control the voltage within the tolerable limits, within the prescribed limits. So devices used to control the system voltage are static wear compensators, SVARs. SVCs and SVARs are ready to control the system voltage. Next, second case is synchronous condensers. So here synchronous condensers are ready to act as overexcited machine. Next is tap changing transformers. So tap changing transformers are also ready to control the voltage levels. Some switches which are provided to control the system voltage. Capacitors, couple of capacitors which will be introduced here to control the voltage levels and to make the system under normal conditions. And one of the reactors case. Reactors, they are also ready to make the system voltage. Another control is called security control. So what is this security control means? This can be done by monitoring and decision action, control monitoring case and decision case, and one with the condition of the system continuity that will be observed in the control centers by relay actions. What a relay can do, ready to act for the current sensing part. That means any excessive currents or shortages happens in the circuits, the relay will immediately opens its switch So this switch can be ready to isolate the path. Isolate the path. If any continuous severe problems occurs in the system under abnormal conditions, then the relays will ready to act immediately. So what is the control over this governor mechanism? Means first we need to give proper commands which are generated for correcting the abnormality in protecting the system. And second one is if no abnormality is observed, then the normal operation process exceeds for next interval. So third case is central controls which are used to monitor the interconnected areas. Next, fourth one is interconnected areas that can be tolerate the large load changes. So with the smaller frequency deviations, this can also be done by the control action. And another one is central control center monitors the information about the frequency, and they will ready to make the generating unit outputs, and they will tie line the power flows to the interconnected areas. And similarly, this information is used by automation loads frequency control in order to maintain the area frequency at its scheduled value. So like that the control action is works. So this is a simple scheme that will be shown how power system operation control can be taken place. Initially, it will be operated to obtain some system generated voltage at a desirable frequency with tie line flows that should be taken place to generate one of the power. And this system generator voltage control is connected to load frequency control, and it is ready to make economic dispatch schedule, and it is ready to finally obtain the system voltage control. So this connection is given to the prime mover and it is ready to control. And here we can expect a field current that is given to one of the generator case here. And here excitation system and control is given to this case. Here we will generate one of the voltage. Here this speed or power can be controlled by excitation system. So this excitation can monitor the system voltage suitably, and whatever the generator, this will ready to produce the power, electrical power, and some of the other generating units, they are associated to control the given line. So these all control blocks are connected to the transmission controls, reactive power and voltage controls, HVDC transmission systems, transmission and associated controls. Here you can monitor the required frequency with tie line inflows which are connected into the system, and here finally you can get the obtained or finalized generated output power. So likewise, the power system operation and control will makes the blocks to control over all the power aspects. What is generator voltage control system? Here generator voltage control system means voltage of the generator is proportional to the speed and excitation, that is with respect to the flux of the given generator. So speed being constant, so excitation is used to control the voltage. So excitation is used to control the means the flux is going to variable, flux is going to be controlled, means here you are going to obtain variable voltage, variable voltage you are going to obtain. So therefore the voltage control system is also called as excitation control system or automatic voltage regulator, that is also known as AVRs, or these may also known as boosters. They can set the required voltages. So for the alternators, the excitation is provided by a device that is another machine or another static device which is called by the name exciter. This can ready to excites the alternator voltage. So for large alternators case, the exciter may be required to supply field current of as large as, which will be about 6500 amps. That means it is approximately 6.5 kiloamps, which is operated at a voltage of 500 volts or 0.5 kV. this much of range of voltages and currents are suitable, and hence the excitation is fairly large machine, so which will depends upon the way the DC supply is given to the field winding of the alternator case. So which is on the rotor side. So the exciters are usually classified as DC exciters. First one is DC exciters. Second one is about AC exciters. What are these DC and AC exciters that we will see now? So another combination existing is called static exciters. So accordingly, several standard block diagrams are introduced that is developed initially by IEEE working team or working group to represent the excitation system. So that is shown here as a schematic model, that is also known as schematic model of excitation control system. That is here. This is the schematic model of excitation or voltage control system. Here is our control block. Here we will ready to apply some reference voltage. So this is given to another control block, and this is going to be amplified here, and this amplified path is connected by one of the exciter, and this exciter is connected with external field winding, that is EF. Here is our generator connected, and this block of the machine is going to be stabilized. This stabilization process is connected to the control action. That means whenever the reference signal is generated from the reference voltage source, this is connected to this block, means the amplified path is connected to the exciter system, and this will actuate the stabilization process. So now the generator keeps to ready to give the voltage. The rectified form is again connected to the input block. So this process is continuous to taken place for every time. So this is the repeating process. So finally generator receiving, and that power is given to the rectifier, that will be collected at the controlling block. So likewise excitation system or voltage control system will be operated. So a simplified block diagram of the generator voltage control system we are observed, in that the generator terminal voltage shown with the V suffix T, this is the terminal voltage, is compared with a voltage reference V reference to obtain a voltage error signal, that is V. This signal is applied to the voltage regulator shown as a block with the transfer function Ka by 1 plus Tas. So the output of the regulator is then applied to the exciter with a block of transfer function that is called Ke by 1 plus Tes. So output of the exciter EMF is then applied to the field winding, which will adjust the generator terminal voltage. So generated field voltage can be represented by one of the block with a transfer function Kf by 1 plus S into Tf. This is the generator field voltage with the transfer function. Now the total transfer function is represented by delta V by delta V reference. So this is as in terms of G of S by 1 plus G of S, where here we consider G of S as K, Ke, Kf by 1 plus S Ta into 1 plus S Te into 1 plus S Tf. So this is one of the function. So the stabilizing compensator shown in the diagram is used to improve the dynamic response of the exciter system. So input to this block is the exciter voltage, and output is the stabilizing feedback signal to reduce the excessive overshoot. That means here is one of the block connected. This is shown with change in reference voltage delta V reference, and this is connected to the amplifier block, which is given with one of the transfer function Ka by 1 plus Sta, and this will control over this control block, and again it is connected to one of the exciter block with the Ke by 1 plus Ste. This is called exciter stabilization, and it is connected with the generator field, that is Kf by 1 plus Stf. So this is connected to delta V of the system. This delta V is again takes the return path connected to the main control block. This is called simplified block diagram of voltage control system. And coming to this governor mechanism, basically power system network is depends upon the synchronous generator, or we may call it as alternator, and its satisfactory performance. So the important control loops in the system are frequency control, automatic voltage control. So frequency control is achieved through the generator control mechanism. So governing systems for thermal and hydro generating plants are usually different, which will be considered in the inertia of water that flows into the turbine. That will represents the additional constraints which are not present with the steam flow in a thermal power plant. So likewise, governor mechanism is ready to operate for the system. So however, the basic principle is still the same, that is the speed of the shaft is sensed and it is compared with the reference signal, and the feedback signal is utilized to increase or decrease the power generated by controlling the inlet valve that will be connected to the turbine of steam or water. So what is this speed governing mechanism? How it will be achieved of various controlled speeds over a system? So the speed governing mechanism includes following parts or blocks, that is a speed governor. It is an error sensing device in load frequency control. It will include all the elements that are directly responsive to the speed and which will influence other elements of the system to initiate the given action. So governor controlled valves are introduced. Those are ready to control the input to the turbine mechanism, and these are actuated by the speed control mechanism. So likewise, the speed controller mechanism is ready to work. So we can observe the block diagram of speed control mechanism. So here it includes all the equipments like levers and linkages, servo motors, amplifying devices, relays that are placed between the speed governor and the governor controlled valves. So speed changer is introduced in this system, that it enables the speed governor system to adjust the speed of the generator unit until it takes into the operation. So this is the mechanism we developed. So it includes all the blocks, levers, linkages, servo motors mechanism. Here we can expect inflow of the water. So governor control valves are introduced and the speed changer will make the change in speed levels, that is delta n we may consider. So what it enables means it enables the speed governor system to control over the speed by the generator. So this will be taken place until the operation is continued. So here pilot valve V operates to increase or decrease the opening of the steam inlet valve V. Let XB and XC be the changes in the positions of the pilot valve V and the control valve V, which is ready to respond to changes in governor position. So XA is due to the load. When the pilot valve is closed, then we treat XB as 0 and XC as 0. That means control valve is not completely closed as the unit has to supply its no load losses. So likewise with these considerations we can adjust to the speed of the governing mechanism. Now it may be the consideration, that is the no load angular speed of the turbine is considered as load is applied to the speed falls and through the linkages the governor operates to move the piston P downwards along with the points A and B. So the pilot valve V admits soil under N and lifts it up so that the input is increased and speed is going to be rises. If the link is removed, then the pilot valve comes to rest only when the speed returns to its original value. So an isochronous characteristic will be obtained with like this arrangement means where speed is restored to its preloaded condition. So with the link B, the steady state is reached at a speed slightly less than the no load speed condition. So which will give rise to drooping characteristics for the governor mechanism. Due to this drooping characteristics, the nature of the speed governing mechanism will be changes which will influence the speed of the system. There will be the more variations in the speed. So a finite value of the steady state speed regulation is obtained with this arrangement. So for a given speed change or position, the per unit steady state speed is defined by the steady state speed regulation. That is steady state speed regulation is equals to N0 minus NR by N. So here N0 is nothing but speed at no load. N0 is speed at no load. NR is the rated speed and capital N is the speed at rated load. So these are the observations we made while we consider the speed change or action. So these are some of the references that I have elected for governing mechanism. So which will give the brief description about the speed changer and its block diagrams. Here we can go for adjustments of the speed with the variable frequency levels, and we can make the governor mechanism to the suitable operation of the system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.